Okay, in this video we're going to talk about reading and writing files in Go. So here's an input file that I downloaded from Kaggle. It's a comma-separated file, so you'll see that the first row contains the titles of the columns separated by commas. Then each row below that is a data row separated by commas. So we have min temperature, max temperature, rainfall, evaporation, sunshine, wind gusts, direction, speed. What we're going to do with this file is we're going to compute the number of entries that have the same wind direction. So we'll find out how many entries have a direction of northwest, for example, at 9 a.m. And then what was the average wind speed in that direction at 9 a.m. So that's going to be our plan. We're going to take this input file, find out how many for each cardinal direction there are, and what the average wind speed at 9 a.m. was for that cardinal direction. So here's our Go program. And what this does is we're going to use buffered IO on standard input, which comes from OS. So you'll see I'm parsing the weather data in this function here. So we read the name of the file, we open that file using the OS open package. And this is going to return two things. It'll return a handle for the file and also possibly an error, because it might be the case that we've given it a bad file name or we don't have permission to read in that folder or whatever. So if that happens, we get an error, we'll just return an error. So you'll see here in the return type, we've added an error as the third parameter. And once again, we're going to be using maps. So this map is going to map from strings to integers. That's going to give us the counts for each of the cardinal directions. And then this is actually just going to add up the wind speeds in each cardinal direction, and then later we'll actually do the average. So you'll see the two maps being made here. We're mapping again from the string, which is the wind direction, to an integer for the count, and then float 64 to add up the speeds. We're using buffered IO to wrap a scanner on this file, and that's going to allow us to read the file line by line. So scanner.scan, you'll see it says it returns a token, but because we've done this buff.io on the scanner, a token is going to be a single line of the file. We trim the space. We're going to remove any spaces at the beginning or the end. And then if it's an empty line, we'll skip it. If it's the very first line, that's the line that had all the titles, we'll skip that one as well. We split that line by commas. So you'll see here that we have a slice of strings. And now we know that index 7 is wind direction. Index 9 is wind speed at 9 a.m. We're going to ensure that there are enough columns on this file. The file that we have here is well formed, but it's useful to, when you're writing code, to add some error handling analysis in case you do end up with bad data. So here we're making sure there's enough columns so we don't have like a panic when it tries to read column 7 or column 9. So we'll get that wind direction and speed stir. The wind direction might be blank or not available. Similarly for the speed stir. So if those happen, we skip that row as well. Again, our file doesn't have any of these malformed data. Then we're going to use the string conversions package to parse this string speed as a float. And so that will give us back, let's see, I specified the bit size as 64. Give us back that speed as a float 64. If we get an error on that conversion, we'll again continue to skip the row. We'll take the wind direction as an index in the map, and so we add to the count. And the nice thing about the maps in Go, again, is that they return 0 if something's not present. So we'll simply add 1 and become 1 if it's the first time we see a particular direction. Similarly, with the wind speeds, it starts at 0, so we can just do plus equal. We don't have to worry about special casing the first element. If we get an error, we return an error. And then after this loop is over, we've read through all the lines of the file. So we return these maps, the maps of the counts, the total speeds, and the nil. So that's going to read in the file. So it's read in all of the counts and the totals. We're then going to write a file with this write method. So this write method will take in a file name to write to. So we now use OS create for that. You'll see the error checking and the defer file closed to make sure that that file gets closed. We have the counts and the total speeds coming in. We possibly return an error. Okay, so now we're again using the buffered IO with the new writer to write the file. We're going to write a header to the file. That write string will return two things, both of which we're going to ignore. So you'll see it returns the number of bytes written and whether or not there's an error. We then write out this header. We're going to write out direction, total entries, average wind speed, and then a line of dashes. We then loop through the counts array. So we're going to loop through that counts array. And our total speed will be the total speed for that particular direction. And then we'll divide by the count and to get our average speed. And then we write out the direction, the count, and the average speed. Here we actually do check when we write out this line if there's an error, possibly returning that. And then we make sure that we've flushed everything because this was buffered IO. And then we're going to close the file automatically. So our main program will simply read in the file, printing out an error if one happens, write out the file, and say the analysis was completed successfully. So here you'll see that I've built and run the program. The analysis is successfully saved. So here's what that looks like. So we have our headers, and then we're printing out the directions, the number of things that were in that direction, and then those averages. So this will give us a basic idea of how to do some simple text file reading and writing. Again, we use that buffered IO package to read a line at a time. We use the string conversion package to be able to convert the strings that we read from the file into numbers. And those are the main elements.